Here's another example of a rational function, but this one has a little bit of an interesting special case to it. When we go to factor our denominator here, we get x minus 2 times x plus 5. But the interesting, unusual part is that one of those factors cancels with the numerator. So when that happens, I don't use both of these factors as my vertical asymptotes. It's just going to be the one that would be left after I would simplify this function, right? Removing the x minus 2. So we have x equals negative 5 as our vertical asymptote. Horizontal asymptotes, we look at the degrees. The degree of the numerator here is 1 versus the degree of the denominator is 2. Just comparing those exponents. So our rules tell us that the horizontal asymptote is going to be the x-axis or the line y equals 0. Then what about the x-intercepts? Well, x-intercepts are what makes this 0, which means what makes the numerator 0. But remember, this x minus 2 can cancel with the bottom. If I put a 2 up here, I get a 0 for the numerator, but I'm also going to get a 0 in the denominator, and 0 over 0 is undefined. So it turns out that if one of your factors in the numerator cancels with a factor in the denominator, it means you don't have a vertical asymptote there. It also means you don't have an x-intercept there. Instead, you have a hole. You have a little bubble there, okay? Last thing, I'd want to maybe try to get a y-intercept. So if you plug in zeros for your x's, you get 1/5 when you reduce. All right, so let's put this in our calculator and see. So I've put the original function here in my y equals. Remember, you put parentheses around those so that it graphs correctly. And I'm going to look at the standard window. Oh, it looks like it kind of stops. Maybe we just need to get a better window. So let's try negative, well, we can do from negative 10, but let's only go up to 5 maybe. And for our y's, let's also bring that in a little bit and see if we get a better thing. Oh, there was our x equals negative 5 vertical asymptote. It doesn't look like it stopped, right? It looks like it just graphed right on through the x equals 2. Let's hit trace and 2. Now here's something. The y is blank. It's not giving me a value. What if I look at the table? Ah, here at 2, it's telling me an error. So that's the only way I'm going to know there's a hole. I have to do some math ahead of time. I have to check those points on the graph, right? So even though it looks like on here it graphs straight through, it doesn't technically. So what would a nice hand-drawn graph look like? Well, it would be this vertical asymptote. And then you notice when we had to the left, we had negative values down here. So you could do, let's say, trace negative 6. And it's at negative 1. So I could use that as a guide here, negative 6, 1. Likewise, I can go on the right side, trace negative 4. And there I've got my 1. So I got a point there and I know it stays here. And then when I'm graphing it on paper, I'm going to make sure I put a hole there at 2.